Okay, so this is science paper one for 2020. The first question is saying how many significant figures are there in the number 0.050200? So before I get to speak about this number, what do you think? How many significant figures are there? Five, huh? One, two, three, four, five. So that's the answer. So when you've got a number with a decimal, all zeros which will come after a number, they are going to be significant. But zeros before a number, they are not. Then if you don't have a decimal, let's say you have got just 200, 2000. So these zeros are not significant because you don't have a decimal in this number. Okay. But if I had a decimal here, then these zeros will be significant. Okay. So that is a simple rule that gets to apply when you're talking about significant figures. Let's consider two. A stone of mass 400 grams is lowered into a measuring cylinder containing water. The water level rises from 300 centimeters to 500 centimeters cubed. What is the density of the stone? Now, what you've been given is you had something like this. The water was here at 300 cubic centimeters before you put in the stone. And after you immerse the stone, the water goes up to 500 cubic centimeters. So how can you find the volume of the stone? Okay, so looking at this one, since you don't know the density, how can you find the volume of the stone? Since the volume of the water before you put the stone was 300 and after you put the stone was 500. So this is volume 2, this is volume 1. To find the volume of the stone is going to be volume 2 minus volume 1. So volume 2 that is 500, volume 1 that is a 300. So that will now give you 200 cubic centimeters. This is the volume of the stone. Now the question is saying find this density. So now you said density is mass over volume. So the mass you can see they've given you 400 grams. The density, I mean the volume found 200 cubic centimeters. So the two zeros cancels 2 into 4, that is a 2. So it will be 2 gram per cubic centimeter. So that is it, and that is option D. Is that okay? Is that okay? Okay, let's consider this one. The graph below shows the speed of an athlete during a race. You've been given the speed time graph. Now, when you have got the speed time graph, the question is saying what distance was traveled. If you find the area under a speed time graph, that is going to give you the distance which someone covered. So all you need to do is find the area. Now you can cut this into different shapes. If you can say this is a triangle, you find its area. You have got a rectangle here, you find its area. If you want, you can also cut this one. You have got a rectangle here, you find its area. You have got a triangle on top there, find also its area. Now, if you want, you can just make two shapes here. We actually have two shapes which you are able to make to be faster. So you have got the O of this one. This is a trapezium, so you can find its area. You also have this one. It's also a trapezium. You can also find its area. So let's find area 1 for the first trapezium. Area of a trapezium. Do you know the formula for area of a trapezium? It's given by half A plus B, then multiplied by H. So you need to know this formula. So that will be half. The A is a distance from here up to here. That's the A. So you can see we are moving from 4 up to 14. So what's the distance from 4 to 14? It's 10. So and then B is from this end again up to here. So we're moving from 0 up to 14, so that would be just 14. Yes. And then the height is the distance from the beginning here up to the end here, which is 5. Good. So this will give us 1 over 2 multiplied by 10 plus 14 is 24, and then multiplied by 5. You know that 2 can go into 24 12 times, and then the answer you get times 5. And then 5 times 12, that is kista, isn't it? So that would be the first area, kista meter squared. But because we're talking about distance, this is going to be kista meter. So that is the first distance. Let's write area 1 as kista, which is the distance 1. And then I'll calculate the other distance of this other trapezium which has remained. Now the other trapezium that has remained, it has just been turned upside down, but the same formula is going to apply. So for the other one, this is going to be half. A is going to be the distance from here up to here. You consider where you have got two, like where I've got two lengths. That is where the A and the B is going to be. So what is A? A is 5. And then B is going to be this distance here. And what will be that? 10. So the height will be this distance between these two. What will be that? 2. Okay. So this is going to give us, we know these two can cancel actually with these two. 5 plus 10 is 15. So that will be the other area in meters because it's distance. So you add 60 and 15. So the answer is going to be 75. That is the distance which was traveled by the athlete. We are good? Okay, so when you find now, you found this area which was the first distance, and then you found the second distance. Now you add them, that will give you the distance which was traveled by the athlete. So it will be 60 plus 15, which is 75. Okay, so question 4. A 4 kg brick is dropped from the top of a building whose height is 30 meters. What is the velocity with which it reaches the ground? So what you have is this. This building is 30 meters. And then you drop a brick. Let me make a brick notice. Okay. You drop a brick from this height, which has got a mass of 4 kg. Now I want to find what velocity is it going to hit the ground. So there are many ways that you can use to find this. You can use work energy theory, or you can use uh, just equations of motion. Now, because you have got the word drop, if something has dropped, meaning that the velocity it is starting with is 0, that is the initial velocity. Okay, you want to find the final velocity, which you don't know. Now, every time when something is falling, the acceleration at which is falling is going to be the acceleration due to gravity, which is 10 meter per second squared. So we're going to look for an equation of motion that has got initial velocity, final velocity, gravity, and height. Do you know any equation like that? Yes, an equation of motion. Mhm. Okay, acceleration is equal to v minus u over t. So this equation actually we rearrange it, and you are going to say v is equal to u plus at. Walimu nakwe? Uh-huh. Yes. So this is the first equation you need to know. The other equation that you need to know is v squared is equal to u squared plus 2as. Okay. And then the third one you need to know there are three. S is equal to ut plus half at squared. So these are the equations that you need to know. Now the s is representing distance. It's not speed. S is representing distance. So because we know the initial velocity, we know the acceleration, and we know the distance. So the equation that we are going to use is equation 2. So you need to know these three because only one might be able to work at a given time. That is why you need to know all of them. So in this case, we are going to use the third one. So that is going to be v squared is equal to u squared plus 2as. Now, when you're talking about something that is freely falling, you can rewrite this equation as v squared is equal to u squared plus 2. Instead of a, when you have got something falling, acceleration becomes g. The distance s becomes height. So this is how we are able to rewrite this equation. So this will be v squared. U is the initial speed. You can see because it was dropped, it is 0. 0 squared plus 2. G is 10. The height is 30. So this will give you v squared being equal to 2 times 10 times 30. That will give you what? 2 times 3 is 6, and then you have got 600. Is this okay? And then now you need to okay, you now need to square root both sides for you to be able to remain with v. So square root of 600, v then is going to be 24.49. So which one do you think is the answer here? B, yes. So you can actually use another method as I told you, that is work energy theory. Okay. Now, when you have got an object that you know this one has been dropped from the top of a building. So when something is on top of a building is able to fall, the kind of energy it possesses here is potential energy because it is able to fall. When it starts falling, by the time it reaches the bottom, all the potential energy has been converted into kinetic energy. So we're going to say potential energy on top is going to be equal to kinetic energy down. And do you know the formula for potential energy? Potential energy is given by mass times gravity times height. And then kinetic energy is given by half mass times velocity squared. So you can see this is mass, also this is mass. So we can cancel them. So we're going to remain, and then I'll get these two, I'll multiply with g this side. So we're going to have 2gh. That is going to be equal to v squared. So I'll square root both sides so that I remain with v. So v is going to be square root of 2gh. So you can find the velocity. Velocity is going to be square root of 2g. We know that is 10. H is 30. To give us the same answer, which is 24.49, which is 24.5. Is this okay? Okay. Let's consider question 5. The diagram below shows an object moving with a constant velocity when a force E of 30 newtons is applied. So this force here, E, is 30 newtons. That's what you've been told. Let me just show that so that will not be confused. Okay. So the E is 30 newtons there. Okay. Are you still able to follow up? Are you able to see still? Okay, so you can inform me if there is okay, now can you see? Okay, so we've been told we are applying a force E of 30 newtons on this object. Now you can see there is also a force going in the opposite direction. What do we call the force that opposes motion? What's the name of the force that opposes motion? Martin, what's the name given to the force that opposes motion?
Fiction.
Friction. Okay. So now remember they've told you the diagram below shows an object moving with a constant velocity. If you hear constant velocity, what will be the value for acceleration? If you hear that something is moving at constant velocity, then the acceleration is equal to what? Have you ever heard about that? Okay, so let's say you are drawing a speed time graph. So if this side you have got velocity, here you have got time. Constant velocity is like this. Now when you have got a line like this, you can't find the acceleration. Acceleration is equal to zero. So when you have got constant, every time you hear constant velocity, just know acceleration is equal to zero. As long as something is not moving in a circle. Constant velocity means zero acceleration. So therefore, what does this tell us? The only way something can be moving, so using Newton's second law of motion. Do you know Newton's second law of motion or the equation for Newton's second law of motion? So Newton's second law of motion, the equation is force is equal to mass times the acceleration. Now this force you are seeing is not any other force but called net force. Okay, it's called net force. I can put net here. The meaning of net force is you get a force going in the forward direction. In this case, that is E. You remove the force which is going in the opposite direction. Okay, that is F. So if these two forces were going in the same direction, then you add them. But because they are going in opposite directions, you subtract them. And this is going to be equal to mass times acceleration. Now, because we've said the acceleration here is going to be what?
Zero.
0. So you put where there is e, they've told us that is 30, minus f is going to be equal to 0. So therefore, if you take f to the other side, f is going to be equal to what?
Hmm. So F is equal to 30.
S is going to be equal to 30 newtons. So that is going to be the answer. So the same force they've given you is going to be equal to the friction if something is moving at a constant velocity. Let's consider question 6. A 6 a 60 Newton object is placed on a uniform bar that was balanced at its midpoint. So this is the midpoint as shown in the diagram. So meaning that if this is the midpoint, let's say this is a ruler, it is 100 centimeters. Okay, it is coming from 0 centimeters. If this is the midpoint, then what will be this point? It's going to be 50 centimeters. Okay. Now they've told us which of the following will balance a beam. Which of the following will balance a beam? Magnitude of the force and then position of the force. Remember what you have. You have got already this 60 kg object which is placed. You can see there is 30 centimeters distance there. Okay, from a midpoint. So if you find you have got what you call moment, because you have put something, a force here, you expect that this thing is going to be moving down like that, isn't it?
Yes.
Okay, so you can find the moment. Now, because this is going to be turning this thing like this, is this clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise. So let's find the anti-clockwise moment. And the moment is given by force multiplied by distance. So that is going to be, the force is 60 newtons, the distance is 30 centimeters. Remember, this is 60 newtons. So 60 times 30, this is going to give us 1800 Newton centimeter. Remember, I'm multiplying a Newton on the centimeter, so it will be Newton centimeter. Now, you want to see which of the following will balance a beam. You want to see where you are going to be able to place another mass, another weight, and what distance you should place it so that you balance this beam. So you want to have, remember this is the anti-clockwise. So you want to have a clockwise moment which should also be 1800 since the anti-clockwise is 1800. So of these options which you are given, look for two numbers you can multiply to give you 1800. Okay, now remember, you are talking about, are you going to place on the right or on the left? So this side is the left, like consider your hand. This is the left hand side, and then this is your right hand side. Meaning that the force that you are supposed to push, you should put it on the right hand side, because if you put it this side, it will still fall all the more. Do you get that sense? Is that okay?
Yes, it's okay. Complete.
Okay. So meaning that this option one and option two, sorry, option 1 and option 4, they cannot be answers. So the two possible answers can be either B or C. Why option 1 and 4 cannot be answers? Because we are saying on the left. You can't place them on the left. So you want a force that will give you 1800. You know that 60 centimeters times 30 newtons will give you 1800. So meaning that this is going to be the answer, because 45 times 45 will not give you 1800. Is that okay?
Yes.
Okay. Let's consider 7. A motor is used to pull. a 10 kg box along a 5 meter long incline to the top of the decline as shown in the diagram below. Ignoring all frictional forces, determine the work done against gravity in pulling the box from the top of the incline to the bottom of the incline. So what will be the work which will be done in pulling the box from the top to the bottom? Now, what do you know any formula for finding work? Okay, so work can be given by force times distance. That is one formula that you're able to use when you want to calculate work. Another formula. Now, this formula you use it when something is moving on the ground. But if you have got something going up, work is given by mass times gravity times height. It's the same as potential energy. So I need to be keeping these formulas. So the mass of the box is 10, gravity is 9.8, and then height, you can see the height of the incline is 4. Sorry, gravity is 10. For you, you use 10. So this is 10 times 10 times 4. That will give us 400 joules. Is this clear?
Look at what saying hadi gwamnati ta kawo Najeriya wai take MTA.
Okay, so every time you are talking about something, you always use height. So never use this distance. Kamonga na mwishiba force ile donsage so. But we don't know what force is pulling in this direction. So you always use mass times gravity times height as long as you've got something going up. Okay, it doesn't matter whether it goes up straight, nangwile kwela incline. So is that okay? Okay. Question 8. A girl whose mass is 50 kg climbs a ladder of height 8 meters in 10 seconds. What is the power developed? So you have got, let's say, a hole here, and then you have got a ladder. They have told us that a girl of mass 50 kg climbs a ladder of height 8 meters in 10 seconds. Now they've just told us a ladder of 8 meters, meaning that the ladder is straight, okay? So not the way I've put it like this. So we'll take it that the ladder is straight like that and it's 8 meters. Now you want to find the power developed. Now power is given by work over time. Okay, but how do you find work? Remember, this is going up. How do you find work?
Wait, force times distance.
Okay, what of if something is going up? Because force and distance you are going to use when you are talking of something like this.
Weight is equals to mass times gravity times height.
Good. And then divided by the time. So mass, the girl they've told us is 50 kg times gravity, which is 10, times the height, which is 8, and then divided by the time is also 10. So see, this time will cancel with this time. The time should always be in seconds. Make sure that the time is in seconds. And then the work, you'll find work is given in joules. So I've got 50 times 8, that is going to give us 400 joule per second. Okay, because I've got joule on top, second down. So joule per second is called a watt. So this is the same as 400 watts. So this will give us the answer. Is that clear? Is that good? Okay. Question 9. A machine with a velocity ratio of 6 requires 800 joules of work to raise a load of 60 kg through a vertical distance of 1 meter. Find the efficiency. Okay. So you have got a certain machine which is supposed to lift something going up. Supposed to lift something going up. Uh, the distance of the what is supposed to be lifted is 1 meter. Okay, it requires 800 joules of energy, meaning that that is the energy that you need to input in the machine for it to work. See, 800 joules of energy. Now, what is it raising? It is raising 60 kg. Now, what is going to be the energy output? So, do you know any relationship between velocity ratio or anything with energy? This is from simple machines. Nothing?
particularly electricity.
Okay. Simple machines. All right. So when you're talking about, maybe let me talk about if you say velocity ratio. What do we mean by velocity ratio? So velocity ratio, which I can also say VR as in simple terms, given as the ratio of the distance moved by the point at which an effort is applied. Now that one is going to be even a bit of complex, the one I'm giving. But we can say velocity ratio is given by the what it, okay, velocity ratio is given by the distance moved by the driver wheel. So if you have got, let's say Namkwata, so this wheel is the one which is moving, and when it moves it is pushing or pulling this one. So I'm going to say how much does this wheel move. Let's say when this wheel rotates for 20 cycles, this one is going to rotate for 40 cycles. So velocity ratio is given by the driver, the one which is driving the other one, the distance it moves, divided by the driven wheel. Okay, so it will be 20 over 40, over driven driver over driven. Is that okay? So there is this wheel which is moving, right? Let's say they are like this, and then you have tied the rope around like that. So when this wheel moves, like it rotates for 20, it makes 20 rotations. Because this other one is small, it might rotate for 40 rotations. You get that? Yeah. So meaning this one which is rotating is the driver. This one which is being rotated is the driven. I don't know if that is okay.
I don't understand. But yeah, it's like it is there.
Okay, yeah, so that is it. So we have got something which is called mechanical advantage. Mechanical advantage. So mechanical advantage comes in when you are doing work. Remember, for example, you are supposed to lift this heavy thing from here up to here. So it will be very difficult, right? It will be very difficult. So for you to be able to simplify your work, what you are going to do is you are going to push it through an incline.